equals GPP minus R, right? NPP equals GPP minus R. So let's see how to read this graph. Okay. So the first one is about the first graph is about the percentage of Earth's surface area. Okay. So this tells us how much area each ecosystem covers. So in this one, okay, so on Earth you can see that the open ocean occupy about 65%. Open ocean occupy about 65%. Okay? And let's see B. B is about the net primary productions, average primary productions. Okay? So, but you can see, student, although open ocean occupies 69%, but it just contributes a little bit of PP. Okay, but the small area, for example, like swamp and marsh, it only occupies 0.6% of the Earth's surface, but it contributes. You can see these three. Especially this one. Algal beds and reef. Algal means reef 藻类, okay? You can see the algal bed reef 珊瑚礁. Although it just occupies 0.1%, but it contributes a lot. Okay, so from figure A and B, they tell us even some small area can be very productive. Okay? Small area can also be very productive. Understand? Okay, small area can also be very productive. Some small country can still be very wealthy, like Dubai. Okay. Some small country can still be very productive, like Taiwan. We provide a semiconductor all around the world. Okay, we produce more than 90% of semiconductor. Okay, to provide the AI or the computer industry around the world. So small area can be also very productive. Okay, and the C is the percentage of the Earth's net primary production. Okay, this is percentage. Okay, so this means the total contribution of Earth productivity. Okay, so from these three graphs, they tell us the open oceans occupy huge, 65%, but the productivity is very low. Okay, so it just contributes around. So this is average. It's a contribute around 24.4. It contributes only around 24% of total NPP. But let's see the tropical. Student, let's see the, I'm sorry, this is tropical. Let's see the tropical rainforest. Tropical rainforest is the small area, occupy only 3.3% of Earth's surface. But it has very big contributions. It's one of the major contributors. It contributes 22%. 22%. Understand? Okay? Okay, next slide. Okay, eutrophic. Eutrophic means there are too much nitrogen. N stands for nitrogen. There are too much nitrogen and phosphorus. Let me rewrite it. There are too much nitrogen and phosphorus. Because nitrogen and phosphorus are nutrients for algae. So algae will grow a lot in the lake. So we also call this algal bloom. We also call this algal bloom, which means algae grow a lot in the lake. And algae will compete for oxygen. Algae will compete oxygen with aquatic animal, right? So algae will compete oxygen with those aquatic animals. So those aquatic animals die. Understand? So we also call this eutrophic. Okay, also named as algal bloom. Algal bloom. Okay, so this is so-called eutrophications because nitrogens and phosphorus. Nitrogen and phosphorus are very good nutrients for algae. So algae will grow a lot. So we also call this algal bloom. Those algae will compete oxygen with aquatic animal. And aquatic animal die. So we call this eutrophication. Eutrophication. Okay, I'm going to skip this. Okay, so let's move on to the matter cycles. Okay, so the matter cycle including like water, carbon, and nitrogen. Okay, those elements keep cycling in our ecosystem. Okay, in our ecosystem. So this is water cycle. Let's see these questions, okay, from the textbook. So the local water balance. So dSdt, the dSdt equals P minus R minus E minus I. So the S means storage. The S means storage. And the P is precipitations, the rainfall or the snow. One second, let me check it out. Okay, and E, let's see R first. R stands for the runoff rate. Okay, runoff. So runoff like this. Some water runoff to the rivers or become the groundwater. We call it runoff. Runoff. Okay, and evapotranspirations. Okay, transpiration mean actually is you can consider transpiration as a evaporation from leaves. So it's an evaporation from leaves. So minus E and also minus I. So I is infiltration rates. Okay, infiltration rate. Oh, we also call it leachate. Leachate for the landfall. Leachate for landfall. Okay, that means the water permeates by filtrations. Okay, so ds dt. Okay, the change of the storage over time equals P minus R minus E minus R. Okay, so let's rearrange this. So the P. So if we rearrange this, then the P equals E plus R plus S. However, if this is at steady state, a steady state means the change. Okay, change becomes zero over time, right? Okay, the change will not vary over time. So if this as steady state, the S will be zero. The change of S will be zero. At steady state, the S will be zero. Okay, let's see this question from the test paper. The 1 kilometer squares water chute has been monitored recently in order to estimate the summer evapotranspirations. During the month of August, the rainfall was 4 centimeters. Okay, the rainfall was 4 centimeters. So it means it's the dips. Okay, the 4 centimeters. The runoff R. So the rainfall will be P, right? The rainfall will be P. The runoff from the area was 5,000 meter cubic. Infiltrations for the area was estimated to be 0.7. So I will be 0.7. Storage assumed to be negligible, so S is 0, which means at steady state. So the change of the storage is not variable, equals 0, right? So the change is negligible. So the first question is, what was the total evapotranspirations? And second question is, what was the evapotranspiration on the average daily basis? Okay, 1 minute for this. Student, can you help me to change this to delta S? This should be delta S, not S. Student, can you help me to change this delta S? Okay, this should be S. This one should be ds dt. This is help me to change this to delta S. Okay? So at steady state, delta S is 0. So delta S equals 0. Okay, let's do this question together, all right? So let's calculate. So student take a look. Okay, student stop, take a look. So we have P, we have R, we have I. But the problem is, student, do you see the unit, the difference of unit? Okay? So this gives us centimeter, this gives us meter cubic, this gives us centimeter. So we need to make the unit consistent, right? So we need to change R to centimeter as well. Right? So because it's over, because question is, because this question means is the dips. So we need to follow the dips. Okay, we need to follow the dips over 1 kilometers. 1 kilometer square area. So actually, 1 kilometer square area equals 10 to the power of 6 meter cubic, right? So make it easier. So R equals 5,000 over 10 to the power of 6. So this equals 0.0005. 0.005 meters. This equals 0.5 centimeter. Okay? So the E, and this one is 0, right? ds dt is 0, right? Okay, I already asked you to change this. Okay, this should be delta S, not S. So ds dt is 0. So P minus R plus P minus I plus R. So I equals 0.7. R is what we just calculated out, right? 0.5. And P is given 4. So the answer will be 2.8. Okay, so but this is dips. Okay, this is dips. This is dips. So tired. For 3 hours. Okay, one more question. Okay, one more question. Then, okay, 2 more questions. Then we're gonna move on to chapter 9. Okay, one more questions. Okay, please do this question by yourself. Okay. So do I have answer for this? Okay. I will give you the answer. Okay. Please do this question by yourself. Okay, please do this question by yourself. Okay. This is very just similar. Similar to the previous one. Okay, let's move on to this one. Okay, this is so-called, we want to calculate the run of R. So R equals C times P. So C is runoff coefficient. C is runoff coefficient. P is precipitations. Okay, so the Q stream flow equals C times I times R. Q equals C times I times R. Okay, times A. So A is the area of essence. Area of essence. So I stand for the intensity of red. Okay? So let's do example 2. Let's do example 2. Those are questions from the test paper. Okay? In 1997, the upper Grants water chute near the Lansing, Michigan, with the areas 4,530 kilometers square, receives the depth is 77.7 centimeter. So what is the average rate of flow? Student, rate of flow equal runoff. Okay, lots of students say, oh, I do not understand this question. So actually, rate of flow means runoff. 可以吗？它这题目没有出现 runoff， 可是有这个字叫 rate of flow。rate of flow 就是 runoff。runoff 就是那些水啊流到河里啊，流到到处流掉的那些。So the rate of flow means runoff. Understand? So and you might also see that this okay the explanation. Drain, right? The drain means runoff, right? If you don't understand rate of flow, at least you know the drain. The drains means runoff. So it's 39.6. Okay, so this question, this is I. So this is I, and this is E. So the question asks us, what is the change of storage? Asks us to calculate ds dt. So asks us to calculate ds dt. Okay, this question asks us to calculate ds dt. Understand? So let's see. Okay, so let's see the answer. Let's see the questions. So student, please take a look here. So R equals C times P, right? R equals C times P, right? So then C equals Q over I and A, right? C equals Q over I and A, right? Understand? So we can plug in this to here. So R equals Q I times A times P. Okay? Okay, A is the area of basins. Okay? So let's do these questions. So area is given. P is given as well. But the problem is they give us centimeter per year. We need to convert this into depths. I is given. So this is I, right? And ET is 45 centimeter per year as well. So student, delta S ds dt, okay? Or you might consider this, you can regard this as ds dt. The change in storage equal rate of precipitation minus rate of, so this is dt, rate of evaporations minus rate of infiltration minus rate of the water flowing. So this is runoff. This is okay. This is runoff. So delta S equal P minus E minus G. Okay. Oh, I. Okay. Or you might also use I. Minus I. Okay. Okay. This time we don't want to use pips. Okay, the unit we want to use is centimeter per year. We want to use this unit. So if we want to use this unit, right, we need to convert I. Student, we need to convert I from centimeter per second into centimeter per year, right? So that's the reason we need to type 60 to turn it into minutes, and type another 60 to turn it into hour, and type 24, turn it into a day, type 365, turn it into year. Understand? Understand? We want to change I. The previous question, we changed everything into tips, right? But in this question, we change everything into centimeter per year. Okay? Into centimeter per years. So we need to type 60, 24, and 365. 因为是秒，先乘60变成分，再乘60变成小时，再乘24变成天，再乘365变成年。Understand? Not finished yet. Okay, not finished yet. After that, we got delta S. We got delta S. So delta S. So delta S is minus 23.9. Okay. The minus means decrease. The minus sign here means water rose. Okay? It means R larger than E. Okay? And the last one, the run of coefficients. Run of coefficients here. So student, run of coefficients, C equals R over P, right? Run of coefficient, C equals R over P. C equals R over P. So 27.6. 27.6 over 77.7. So the C will be 0.36. Okay? Okay? Okay, I think that's it for the. I'm gonna skip those things, okay? So that's for the biology parts. Okay, that's for the biology part. I want to move on to the chapter 9. Okay, student, please. I forgot to. Please go to our Moodle. Not Moodle. I haven't uploaded to Moodle. I'll upload to Moodle later. Please go to our online group. Okay, everyone in our online group, right? Please go to our online group and download the chapter 9. Okay, please go to our online group. Okay, please go to our online group. Okay, I already put a file here. I will upload to Moodle later. Okay, can everyone download this? Can everyone download this? If not, so I will upload to Moodle. Okay, I will also tell you how to submit your assignments. assignment submit link. Okay, maybe here's. Okay, then you can upload your assignment. Okay, if you don't know how to do it, please let me know. Okay, I will ask TA to help you. Understand? And so our assignment will including chapter 0, chapter 1, and chapter 2. Okay, and chapter 2. Assignment 1 will include this chapter. Okay. So you might go to Moodle to download this file. Okay. You might go to Moodle to download this file, or go to our online group to download this file. Okay, that's good. Okay. So let's start from the chapter. Finally, we already reviewed all the knowledges, including chemistry and biologies that you might need for environmental engineering 1. Okay. So, as I mentioned, keep that in mind. The deadline will be April 12. Okay. And keep that in mind that you need to submit all the assignment in order to pass. Okay. In order to pass, you need to submit all the assignment. Okay. Let's see. So, in this chapter, we are going to talk about the air pollution. And I would call air pollution a silent and invisible. I will call air pollution a silent and invisible killer because you cannot kill it. So let me show you the key fact from this organization. Okay, this organization belongs to WHO. So every year, about 7 million people die because of air pollution. Okay, it's pretty close to the death number of COVID-19. Okay, so that's the reason you do not notice, but it affects our life. Okay, so I call the air pollution the silent killers. You cannot see it, but it still harm your body. gradually. Okay, gradually. So normally it will happen like stroke, 中风. Okay. So normally you will have some risk of some major disease like stroke, like heart disease, or like some respiratory disease like asthma, 气喘 asthma. Okay? Okay, so it's about like 29% of the people die because of air pollution caused by lung cancer. So it's a contribution to the deaths due to air pollution. 29 students, you don't need to memorize those numbers, just give you an idea. It's about like 30% people, 20% of deaths from cancer, lung cancer. 24 from stroke, 25 from heart disease, 43 from lung disease, like asthma. Okay? You might also regard the heart disease, cardiovascular 心血管 cardiovascular disease. So the effect of air pollution, including the damage to human health and welfare, as I mentioned, the disease. So it lower the life expectancy. Okay, because for example, without air pollution, you might live until like 100 years old. But because of air pollution, you might die earlier, like 70 or 80. Okay, so it will reduce our life expectancy. It will damage vegetation like crops and animals. So the ecosystem, as we just mentioned, the ecosystem will be imbalanced. The ecosystem will be imbalanced because of air pollution. Okay, and our property, those buildings might be damaged. Okay, including abrasions. Abrasion means the particle wear surface. Depositions and removal. Okay, so those dust will accumulate. Those dust from the air. And some chemical attack, for example, like acid rain. Indirect chemical attack. Okay. And electrochemical corruption, for example, like rusting. Okay, it will also damage to our atmosphere, soil, or even water. Okay, so let's finish here. So the key takeaways that air pollution is invisible, but actually it's bad. As I mentioned, from the statistical data, right? So this is data from WHO. It's around 7 million people dies every year. Okay, this number is pretty close to the people dies, okay, due to COVID-19. But you do not notice this. Okay? And not just that, it will also affect, okay, it will also damage our properties. Okay? So that's for today. Okay? That's for today. And assignment 1 will not include aberrations. Okay, this will be covered.